Okay, welcome. Today we're going to look at solving quadratic equations by factoring, but this time we're looking at problems that have larger numbers. So how do we handle factoring with larger numbers? So that's kind of our objective today. Okay, go ahead and take your notes out and we'll get rolling. Remember the usual, if you fall behind, to pause the video and get caught back up, or if you didn't quite understand something, rewind the video and listen to it again. Sometimes it takes a couple times through. Okay, so the equation we're going to look at today is 42x squared plus 10x is equal to 8, and we're going to solve it by factoring. Okay, so the first thing I notice is we do have larger numbers, so let's figure out how to do or solve with larger numbers. Okay, step number one hasn't changed. We're using the zero product property, and a quick reminder, that's if a times b is equal to 0, then a equals 0 or b equals 0. Okay, so the first thing we're going to do is make it match the if statement, and that means we need to set it equal to 0. So let's do that by subtracting 8 from both sides. We get 42x squared plus 10x minus 8 is equal to 0. And now we need to break up our expression into two smaller expressions, an a times a b we'll call it. We're going to do that with factoring. Now our first step in factoring, remember, is always the greatest common factor. And I noticed that 42, 10, and 8 are all even numbers. And it looks like our greatest common factor in this case would be 2, because 4 doesn't go into 10 or 42, and 8 doesn't go into 10 or 42. So it looks like 2. So pulling out a 2, we're left with 21x squared plus 5x minus 4, and all that's going to equal to 0. And while we do have 2 times an expression, I can see that this expression is probably going to need to be factored even more. Okay, so pulling out a 2 left us with smaller numbers, but they're still quite large, as we're going to see as we hit our factoring technique. So first step is the first term coefficient, or leading term coefficient, times the constant. So negative 4 times 21 is a negative 84. And I want factors of negative 84 that add up to our middle term, which in this case is 5. And you can see factors of 84, if 84 is not a common number, so we can go 2 and 42, but there's an easier way. When you can't see the factors quickly, we're going to go to a factor tree. So let's break down 84 into its product of primes. So it looks like 4 and 21. 4 breaks down to 2 times 2, which these are prime numbers, and 21 breaks down to 3 times 7. So we're going to use the numbers, or factors, 3 times 2 times 3 times 7, which still equal 84. But now we're going to group factors and try to find the 2 that will give me 5. Okay, before we start that, let's use a little logic. Because 84 is negative, I know my signs are opposite. Okay, because a positive times a negative is a negative, and because the 5 is positive, I know my larger number has to be positive. Okay, let's start breaking down 2, and breaking down simply means I can go 2 times 3. I'm going to group those together. 2 times 3 is 6. And that leaves me with 2 times 7, which is 14. And since the larger number has to be positive and the smaller one negative, 14 plus a negative 6, or 14 minus 6, same thing, is equal to 8. Okay, not 5, so that wasn't the grouping we needed. Okay, so I'm going to try another set of grouping. This time I'm going to group, let's try 2 times 2 times 3. I'm going to group those together, and that is going to be 12. And that leaves just 7 on its own. So I'm going to try 12 and 7. Larger number positive, smaller one negative. When I add these up, hey, I get 5. These are the factors I want to use. So by simply looking at grouping, I can arrive at the factors I'm looking for. Excuse me. Okay, let's finish up this problem quickly. So I want a positive 12 and a negative 7. So simply by dividing by the leading term coefficient, which is 21, 7 over 21, remember negative, will be negative 1/3. Positive 12 over 21 reduces down to, have a common factor of 4, or 3, excuse me, 3, of 4 over 7. So we can rewrite our problem as 7x plus 4. And our next one's going to be, using the negative 1/3, bringing the 3 in front, that would be 3x minus 1. Now by factoring, we have 2 times this expression, this times this next expression equals 0. So using our zero product property, that means we hit the if statement. Now we use the then statement. When is a 0, b is 0? Well, if this term is our a, we can say 7x plus 4 equals 0. And that means the value of x we need will be, through solving our two-step equation, will be negative 4/7. And here's our b. Set that equal to 0. And that means we add 1, divide by 3, so our other value will be positive 1/3. I know I rushed through the last solving part rather quickly, but that's stuff we need to know. The main focus was, how do I arrive at these two factors, 12 and negative 7? And again, that was using our factor tree, breaking it down to its products of primes and grouping the different factors until I found 2 that added up to 5. Okay, if you have any other questions, jot down notes and ask me in class, and I hope this helped you out some. Thank you.